Imagine we have a circle, and an isosceles trapezoid is drawn around it. This means the circle is inscribed within the trapezoid. We know the diameter of the circle is 15, and each of the non-parallel sides, also called legs, of the trapezoid is 17. Our goal is to find the lengths of the two parallel sides, known as the bases of the trapezoid. Step 1. Understanding a property. When a trapezoid can have a circle inscribed inside it, there's an important property. The sum of the lengths of its parallel bases is equal to the sum of the lengths of its non-parallel sides, or legs. Let's call the non-parallel sides AB and CD. We are given that AB equals CD, and both are 17. Let the bases be BC for the shorter base and AD for the longer base. So according to this property, BC plus AD equals AB plus CD. Plugging in our given values, BC plus AD equals 17 plus 17, which sums to 34. Step 2. Finding the height of the trapezoid. The diameter of the inscribed circle is equal to the height of the trapezoid. We are given the diameter is 15. So the height of the trapezoid, let's call it CE, where E is a point on the base AD such that CE is perpendicular to AD, is 15. Step 3. Using the Pythagorean theorem. Since the trapezoid is isosceles, if we draw heights from both top vertices to the bottom base, we form two right-angled triangles at the ends. Let's consider the right-angled triangle CDE. Here, CD is the hypotenuse, which is the leg of the trapezoid. CE is the height we just found, and DE is part of the base. We know CD is 17 and CE is 15. Using the Pythagorean theorem, which states a squared plus b squared equals c squared, or in our case, c squared minus b squared equals a squared, DE squared equals CD squared minus CE squared. DE squared equals 17 squared minus 15 squared. DE squared equals 289 minus 225. DE squared equals 64. Taking the square root of 64, we find that DE equals 8. Step 4. Relating the bases. In an isosceles trapezoid, when we drop perpendiculars or heights from the endpoints of the shorter base to the longer base AD can be expressed as the sum of the shorter base BC and two segments like DE. So AD equals BC plus 2 times DE. We found DE to be 8, so 2 times DE is 16. Therefore, AD equals BC plus 16. Step 5. Solving for the bases. Now we have a system of two equations with two unknowns, BC and AD. Equation 1, BC plus AD equals 34. Equation 2, AD equals BC plus 16. Let's substitute equation 2 into equation 1. BC plus 16 equals 34. This simplifies to 2 times BC plus 16 equals 34. Subtract 16 from both sides. 2 times BC equals 18. Divide by 2. BC equals 9. Now that we have BC, we can find AD using equation 2. AD equals BC plus 16. AD equals 9 plus 16. So AD equals 25. Answer. The lengths of the bases of the trapezoid are 9 and 25.